Hello everyone, welcome back to my channel, your go-to destination for exploring the latest in Google Cloud. I am Mustafa and today we are diving into BigQuery, which is Google's fully managed NoOps and low-cost analytics database designed to help you analyze massive datasets with ease. With BigQuery, there are no infrastructure to manage and no need for dedicated database administrator. Using SQL and a pay-as-you-go model, BigQuery empowers you to focus entirely on uncovering meaningful insights from terabytes of data, all without breaking a sweat. In today's session, we are working with an exciting e-commerce dataset containing millions of Google Analytics records from the Google Merchandise Store. Here is what we would explore: understanding the dataset, removing duplicate information, and diving deeper into data analysis. This hand-on walkthrough would help you harness the power of BigQuery to analyze data and uncover valuable insights. Whether you are a beginner or a seasoned professional, this lab would provide you with practical techniques and basic practices for working with BigQuery standard SQL query syntax. Ready to unlock the secrets hidden in your data? Don't forget to hit the subscribe button and the like button and grab your notepad, and let's get started with BigQuery. As usual, we'll start our lab by clicking on Start Lab. Then you launch the lab with the required credits. So after launching your lab, you open your lab in an incognito window so that it does not tamper with my personal resources. So I'm going to grab my password alongside with me. The email is automatically copied. Paste in my password here. And I have my Google account. So click on I understand. So it's setting up my Google account dashboard. So I'm just going to agree to the terms and service. And here we are. So diving straight into the lab for task one, we want to start the lab project in BigQuery. So we have a project that we are going to majorly work through, and we have to start the project so that we can have it in close proximity with what we are doing. So let's go back to our account. So from the navigation menu, click on BigQuery. Let's dive into BigQuery. So from BigQuery, we have a whole lot of projects. This is our project account for this lab, the default one. But we also have some projects that may be a little bit hard to see. So when we click on this plus, you can easily get the project that you want to use. But I just want to start a project by the name. I know the name of the project that I want to work on. We'll just paste our name here. And what to do is explore the e-commerce data and identify duplicate record. So we have some data sets in our project. Let's take a look at them. Let's just take a look at the all sessions raw. So let's expand our data set here. After expanding it, we have our, this is e-commerce, from e-commerce. So this is the project, this is the data set, and these are the tables in the data set. So we have our all sessions raw. Let's click into that. So you can just do a preview of how the data set looks like. This is the schema, which contains the column names and the corresponding type for that particular column. So if there's a description, the description can also show up here. So we also have a details tab whereby it contains the information about the table, like the table ID and the number of rows it contains, the logical byte, just pretty much information about the table. So you can also preview a table in BigQuery. A preview gives you an idea of how the data is and what each row contains. And you can keep going till you see till you get over all the data. Yeah, so that's just the three parts I'm going to show for now. Let's go back to our instruction. So we viewed the table and I've explained all these parts. So let's answer some of the questions here. Which UI tab will show you the data type? So as you can see from the UI tab that will show us the data type, it is the schema, and you can see the data type here. So just going to select the schema and submit. How many rows are in the data set? So let's go back to our table. For that, we can know that from the preview. We can know that from the preview, and we can also know that from the details. So from here, we can see this is over 21 million. And if you go to the details also, you can see number of rows under the storage info, 21 million. So that's fine. submit this also. So the next thing is let us identify some duplicate rows. We notice that there are some duplicate rows in there, and we want to just identify them. So it's a really good motive to always check for duplicate rows when you want to jump on any data set, any new data set you want to explore. It is good to check for duplicate rows and know if you are comfortable with those duplicate rows or you just want to eliminate them entirely. So here is the query we can use to check for duplicate rows. So we'll go back to our data, click on this plus section, and paste our table here. So you can also format your query to be more readable. So when you format them and you have a standard SQL, which so this SQL is doing a select count of star as and we are naming that number of duplicate rows. And we're also selecting everything again from this data set. So we are grouping by all the columns and we are putting an having clause where this number of duplicate rows is greater than one. So what we are typically doing that we are comparing all the columns in the table, all these columns outlined there. And when we compare all the columns, we want to see anywhere that two rows, all the values in each column under two different rows matches one another. So when they matches one another or more, we would take that as duplicates. So we want to just show how many duplicates exist in this thing. So when we run this, so running this, you can see the duplicate rows that we have here. So duplicate rows, the visitor ID, the channel grouping, and everything. So these are duplicate rows. And how you can confirm this is really a duplicate row, you can confirm. I can also confirm. A good way to confirm is let me just grab this query and do some analysis. So when I paste this query here, I'm just going to select star, and I'm going to say where I'm just going to select some columns from this. So let's use this full visitor ID. You can see that for this one, the one on number 10, it's telling us that it has four duplicate records. So let's see if we can see the four duplicate record. So this number 10, yeah, the full visitor ID is this. So just going to say where full visitor ID equals to. Let me paste this inside for row 10. And we'll see the four records that are calculated under this. And I'm just going to use another identifier also so that I can reduce the entries that are going to show up. So let's say time equals to this. You can also use another identifier to just narrow it down to show the four records. Don't forget that if any column happens to be different, it's going to count it separately. So we want to see the full one that are the same thing. So let's just okay, let's say city equals to New York also, and city. This is just us checking our query. So let me confirm the spelling of New York here. Okay, it's fine. So I can run this query. And when I run this query, you can see the four records. These are the four records that shows the same values all through. So they have the same value all through. And you can also see them here that for this number 10, it has four records. So this is show that it's really a duplicate. And we've just verified that. So another thing you can do to this query is that recently Google BigQuery allows you to use group by all. So instead of you having to write everything together, you can just say group by all. So you can see this is 615. When I run it again, it's still going to have the same effect instead of me outlining all the columns one after the other. And you can see our data. We also have 615 here. And that's really what we want to do for now. So we are done with that. So it's asking us how many duplicate records are in all session raw. So all session raw, we have 615 duplicate records, and we can just click on them and submit. So here is a note. In your own data set, even if you have a unique key, so there are some data sets that have a unique key for each column. Let's say you have a primary key and it's unique, but it's also still beneficial to confirm the uniqueness of your row using count, group by, and having. So just like what we did here, and I showed a more simpler way, which is something like this. So just change You just have to change what the data points to. So just point to the data set that you are really interested about. And like I've said before, this is the project name. So data to insight is the project name. The e-commerce is the data set, and all sessions raw is the table. So the table is in the data set, and the data set is in the project. So that's regarding that. So let's analyze the new all sessions table. So we have the deduplicated table, which is the all sessions. You can see that this one that we have here, all session raw, it contains duplicate. The deduplicated one, which is all sessions, it's here. So so what I'm just going to do is I'm going to change this table to point to all sessions. And I'm just going to run this query again and we'll see if we have any duplicates for this one. So just going to click on one. Let's see if we have any duplicates. So you can see that for this one, we do not have any duplicate role at all, which is because this particular data set has been deduplicated. So yeah, good. And so if you run this query also, you see that nothing is going on. So this query is just similar to what we did before, but instead of doing star, they put the column individually. So I'm just going to replace it with what is there, and I'm going to format it also. And also another thing you can also do when writing queries, that instead of you putting the name of the columns, the name of the columns here, you can use 1, 2, 3, 4 till the number of columns that you want to group by. So anything after the hash is a comment, so they are not going to be considered in the code when the code is executing. So if I run this, we should also have no results because, like I mentioned, this is the duplicated parts of the query. So let's wait for it to show the result. And we can see we do not also have any data, which is fine. So yeah. So for task 3, we want to write basic SQL on e-commerce data. So let's play with SQL and see some of the SQL we can just write for this e-commerce data. So we have a query that shows the total unique visitors. And I'm just going to explain the query, but let me grab it and go to our SQL editor. So if you need a new editor, you can click on this plus sign, paste it here. And a good thing to always do is to format your query so that it can be more readable. So this is our query. It's formatted now. So what this query is doing is that it's counting it's counting star. So counting star means just count everything in the table, and its group like count the number of rows in the table. So something like that, counting the number of rows in the table, and it's also doing a count of distinct visitor ID as unique visitors. So we want to know who are the unique visitors and how many views have they done. A visitor can view multiple products. Do you understand? So we want to see for each visitor how many products has it viewed overall. So when we run this query, so this is the result. So you can see that we have the product view, which is the total product view that we have is just all the rows in this all sessions table. So if I want to preview this all sessions table, just like how I previewed the all sessions raw. So what I did was just um, place my hand on the command button and use the my mouse to toggle this. So and you can see the prompter here. So open resource side by side by using command plus click. Okay, so this is the table, and I can also do the preview. So this one contain also above 21 million. So you know that the all session raw contain more than this but this one is a little bit reduced because we've removed the duplicate. And yeah, that's pretty much about that. So when we did our count star, this is the total that we have. So that is the value that we have here. And the unique visitors. So the unique visitors that comprises of these views are 389,000. So that's about that. So another thing is that let's also write a different query that shows the total unique visitors by by the referring site. So let's see how did they get to our platform? From where were they coming from to get to our platform? So to just do that, we'll use this query. I'm just going to close this tab out. Then we can have our plus sign here. And I'll also just try to format this query. So what we are doing here is that We are also checking the distinct visitors as unique visitors. We are now grouping them by the channel. So we want to know that for a particular channel, these are the total unique visitors that came to this channel. For another channel, these are the total visitors that came to those channels. So, and we are also using the same table. So click on run. So when you group by make you have distinct information based on a particular criteria. So you can see. So this grouping by the channel grouping are what make us get for each and every unique visitors. This is the number of people who comes from that particular channel or who came from that particular channel. So the grouping by help us to see the information on a granular level. We can know that, oh, for this particular channel, these are the number of unique visitors. For this particular channel, these are the number of unique visitors. And we can see for every one of them, social referral, paid search, and others. So that's also about that. And this is pretty much what we have here. So another thing we can also do is that let's list the unique product names that are in this particular data set. So there are two ways we can do this. I'm just going to replace this with this one, and I'm going to format this. So, like I said there are two ways you can do this. Let me open a tab to the right so that I can do it in two ways. There are always plenty ways to skin a cat. So, what I'm just going to use here is I'm going to use distinct. So when I use distinct, I can remove this group by. I don't need a group by here. And both queries should have the same effect. So when I run this, and let me run this. So you can see I have 633 information here. I've also 733 information here. So what we are just pretty much doing here is that we are checking the distinct product name. So you can use a distinct syntax or you can just use group by also. So that's about that. And what part of the previous query deduplicates the record? It is the group by. So the group by helps us to know what we want in a particular format. So that's about that. How many distinct product names were returned in total? So from both sides of the query, we have 633, 633. So just click on and submit. Yeah. So the next thing we can also do is that we want to write a query to list the 5 products with the most view from all the visitors, including people who have viewed the same product more than once. We also want our query to count the number of times a product was viewed, you understand, and put them in descending order. So we want to limit our results to just the top 5 entries. So to do that, just going to replace this query here so I can delete this other split tab here. And I'm counting all the rows as the product view. BigQuery automatically do this to just you automatically in the background choose the best way to run this query. So in a case whereby you have a primary key, you could just be the primary key that is going to actually get run and not loop through the whole columns. So we have the V2, we have the product name, which this is just us naming this V2 product name as product name. So we are selecting from our particular table. So we are putting a type. So we are setting a type of page and we are grouping by this thing. So grouping by this V2 product name is going to help us show for each product name, this is the count of the views. So and we'll order by the count of the views. So we are ordering in descending order so that we can see the top 5 descending. So when we run this, and this is our result. So for Google's men, so let me just expand this thing here. Yeah, expand it here. So Google's men, 100% cotton short sleeve Euro T white. So this is the total views. And the funny thing with BigQuery is that you can also do ascending and descending here. We did descending here. I can change this to ascending just by clicking on this thing here. And let's see ascending. And you can see we now have ascending. So that's pretty much about that. So we can see the results. So another thing we can add to our query is that we don't want it to do a double count for visitors who have viewed the product many times. We want to get each distinct product view. That means we only want to count one view per visitor, one view per visitor. So how could we also get that? So just from the same query, from a similar query that we are using, would would first attempt to deduplicate. And I'm going to explain this query in a bit. Let me format it. So after formatting, so this contains what they call common table expression, which is CTE in when you're writing SQL. So we have a CTE. So this is, you can see this part is a query on its own. It's a subquery on its own. So this query is also a query on its own. So this query can run independent of one another. So I can easily run this query. So what I'm saying is that when I run this query, it collects the result somewhere. It now runs this other query from the result of the first one. So that is really what this query is doing, and that is really what common table expression does, or what they call subqueries. So this is a subquery. We are selecting the full visitor ID and the name, and we are grouping by the visitor ID and the product name. So that means it's going to select the distinct for each visitor ID, a distinct product name. So it's just going to do the counting once. So for each visitor ID, the distinct product name. And then thereafter, we'll now select everything. All the selection that is going on here, it's on the result of what is there. So we'll select star as the unique view count, then each product name. Here we've duplicated already. So let's run this, and we'll just see the unique view count. So you can see the unique view counts for each and every one of them, and you can see the product name. And like I also mentioned, typically there are various ways to do this. I can attempt to do it in another way without using a subquery. Let me attempt to do that. So I'm just going to grab this. Yeah. And what I'm just going to do is that I'm going to do a count distinct for full visitor ID, and I'll call it full visitor ID. And we have the product name here. So I'm going to remove this from the group by. I don't need it again. And when I run this, it should also give us the same information as this. So I just have to um, do the descending. So when I do the descending and I limit by 5, I should be good. So I have to add my order. So order by. So in this case now, this thing here, it's what's really doing is the unique view count. So when I come here, I can do the unique view count. I can change this to unique view count. So when I order by this is this and this. So all what is going on here, let's run it and let's see if you give us the same thing. If you give us the same thing. And you can see that the same answer that we got through this one, it's also the same answer that we are getting through this. So, like I mentioned, there are plenty ways to skin a cat. So that's about that, and that's just our information. So we can also expand more on our query and say, um, let's make it include the total number of distinct products ordered and the total number of units ordered. So what this really means, let me paste it here and do a thorough explanation. So I'm going to close this one out, then going to format this. So what we are doing here is that we are selecting our count, which we are counting all the rows in the code in the table. Then we are counting the product quantity. So when we count the product quantity, which is the orders, we are also now summing the product quantity. So summing the product quantity means, so you can make an order for multiple volume of that item. So we want to look at the distinct orders and the quantity, the sum of all the quantity ordered also for each product name. And we are just limiting it to the top 5. So click on one. So we have this information here, and like we have here. So we have the product view, we have the orders, and we have the total quantity orders. So what this really means is that for Google Men's 100% cotton short sleeve EOTY, so the total total number of orders, like total number of these products that were ordered were 6,352. And that happened through 3,158 orders. So some people did multiple orders, like they made multiple purchase of shirts at a single order. And the amount of time that this product was viewed was 316,482 times. So that's regarding that. So let's answer some of the questions that are here. The product with the most views got the most order. So let's take a look at it and answer that again. So the product with the most view, how do we know if that product really got the most order? How do we determine that? So this is where's the product with the most view? So this is the product with the most view. But does it add the most orders? No, because we have this YouTube custom decals. So it had 11,336 orders, and yeah, it was not the most viewed. It was the one that was ordered multiple times. It was the one ordered the most time. So that's really first here. First, sorry, I mistakenly chose two was first. So what is the difference between orders and quantity product ordered? So I think you should be able to answer this. So nothing, they are the same. That's wrong. Orders is the number of ordered. Quantity product ordered is the number of items available to be ordered. That's also wrong. Orders is the number of ordered. Quantity product ordered is the number of item ordered. So this is more correct. And that's about that. So for the next task, let's expand the query to include the average amount of product per order. So when we want to look at that for each product, what is the average amount of products per order, like for each product? And that's really just saying what is the total amount, what's the total quantity that was ordered divided by the total amount of time that those orders were done. So and it's really just adding this particular line to it. So this particular line that's here, it's really just adding that. So we can go back to our previous query and just add that here. So we have the new thing here, then we can run. So now we now have the average per order also. So let's go back to our instruction. So which product has the highest average per order? So how can we get the highest average per order? Like I mentioned, you can easily do descending and ascending here. So let me do descending. So we have 22 OZ YouTube button infuser. So that comes first. Yeah, so that's about that. So, and for the last task, which we want to practice with some SQL, they want us to show our SQL prowess and see some of the things we can just play with SQL. So, the first thing is let's write a conversion rate query for products with these qualities. So, the first one is that there should not be more than 1,000 units that were added to the cart or ordered. And the next one is that we want to exclude a product called frisbees. We want to exclude a product called frisbees. And the next one is so let's first do that, then we can answer these other questions. So let's copy this query here, and I can easily just replace all this one. Then I can format my query to be more readable and beautiful. So this query is not complete, and you can see that it's throwing an error, and it's also showing us where the error is coming from. So it's telling us that there should be something before this order by. The greater by cannot just greater than cannot just follow order by. So and from the instruction they said it should be greater than what 100. So more than 100 units were added to a cart or order. So we are checking the quantity product added. So the quantity product added should be greater than what 100. So we are having that. And so this cannot happen in the where clause. This quantity added greater than 100 cannot happen in the where clause because it is a computation that we are doing here. So we cannot add it to the where clause. We have to add it at in a separate end in the having clause. And that's really the difference between where and having. So something that you're using in the computation cannot happen in the where clause. That's to happen in the having clause. So that's about that. And so the other thing, so we can say that we are still getting an error conversion rate. That means we have to do a summation and name that summation conversion rate. So let's go back to the instruction. They said write a conversion rate query for products with these qualities. And what really can denote conversion rate? So what can denote conversion rate is sort of the the amount of time that a product was viewed divided by the orders that was done. So I could use that to denote conversion rate and say count star. So I'm just going to say okay, count star divided by quant product quantity as conversion rate. So this is case insensitive. So you can see that it's not showing an error and I'm using the smaller AS. So you can wrap all these ones in a bracket or you can just leave it like this. But so that mistakes don't happen, you can wrap everything in a bracket and then click on run for our conversion rate. So now we are getting different conversion rates here. And let's take a look at the solution and see if we are close to what we are doing. So it's supposed to be this divided by this as the conversion rate. So that's more often than not, it's still fine. It just depends on how you interpret it. But if you would interpret it in the right way, we can just switch this one and to just switch that. I'm just going to do Control F. Then put the slash here and add this. Then remove this one. So what we are really doing here is that so we are checking the potential order. We are checking the potential order and we are looking at the count of the time that divided by the count of the time that it was viewed. So that would give us that would make us have our maximum value to be less than one. Do you understand? In a case whereby both of them are equal, then that's the highest. The other one I was doing before was closer to being a percentage. So this is which is what we really did here. So we have the conversion rate, we have the count of product quantity divided by the count of star, and this is the conversion rate for everything. And don't forget that we are also ordering by conversion rate. So when you don't add anything here, either descending or ascending, it by default does ascending. So when you don't add anything, by default does ascending. And what is here is really ascending. If you want to do descending, you can change to descending here, or you can also change to descending from this part. So let's keep going. So for the next challenge, we want to track visitor checkout progress. So let's see how visitors are checking out and what are the things that they are doing for each type. So at what stage are they sort of like dropping? So we have a possible solution here whereby we can play with and look at some things. But we are also going to make it better. So let's format this. When you format this and run it, you have the details here. So you can see that for each action type, we have the number of unique views that drop at that particular action type. But this is not so logical. So let's expand it. Let's make it more readable to the human eyes. So what we are going to do is that for each and every of these numbers, we are assigning a type to them. So for each of these number, we are assigning a type to them. And that's really what this query is doing. So I can just grab this query. And there are also different ways whereby you can do this thing. Let me split it to the right and do some things. Um, Let me paste this query here. So we have this query here, and we can do this. So this is where we are using case when. So this is sort of a short form for case when. So another way that we can also do case when, which is a little bit more stressful, but we're still going to get to the same answer, is by using the case when as it normally comes more often than not, which is saying case when. So yeah, we are now doing it one by one. We'd say case when this one equals to 0, when I say then this particular value. Do you understand? So then this particular value. But this is pretty much stressful. It's pretty much stressful. And let me just finish it actually. And I'll change what I'm supposed to change. So, but that's this one that we have here. It's a really short form. And to do that. So to do that, I'm just going to I'm going to add this e-commerce after when. So then I'm going to say, okay, so when I've done something like this, now it should also work. It should give us the same result as this. But this is more faster because you don't have to repeat this e-commerce type every time. You understand? And yeah, so let's wait for this to process. So we've run this. Let's run this again, and you can see that the information is just the same. It's just the same as what we want. So we can see all the information here, which are just the same as what we want. 0, 1, 2, 3, and the count are also the same thing. Yeah, so that's regarding that. So another thing, what percentage of visitors who added to the cart completed the purchase? So from this one, we can see that percentage of visitors who added the cart. So who added the cart is 3. So 3 is for those who added the cart. So we can see when they added the cart, we have 56,000 added the cart. But how many completed the purchase? 19,000 or just close to 20,000, they completed the purchase. So doing the division that way can work to get the percentage. And that's what we can get from that. So the last part is to track abandoned carts from high quality sessions. And what do we use to represent high quality sessions? So we'll get to that when I'm explaining the query. So let me just close out of this. And we have this here. And let's format this, then run it. So we have our information here. And what this thing is telling us is that we want to look at high quality abandoned carts, people who got to the progress or who got to the stage of adding to carts. So we can see that the checkout progress, when the checkout progress is 3, it also means that they've added to carts, which is just similar to what we were doing with the so you can see we are doing e-commerce action type. So this e-commerce action type, and it is set to 3, or it's set to 3 here. So having checkout progress equals to 3. So there are different ways you can sort of write this and see what's going on. But this is also a good way to get the information. So to get our session ID, we are concatenating. So when you concatenate means join something together. So we are joining the full visitor ID and the visit ID together. So we are joining them together, and we are having it as a string. Then we are selecting the session quality dim. So session quality dim is set to greater than 60 hours. And greater than 60. I don't know the denomination that it is. So the session quality dim, we are saying that for high quality session, we want to look at something that is greater than what? 60. So we've done that. And we have the sum of our product revenue and our transaction revenue, and we have the max stuff here. So we have it here, and we are using our having. So having the checkout progress should be equal to 3, which is representing added to cart. And we are also doing a check. So we want to check for transaction revenues that are equal to 0. So when the transaction revenue is equal to 0, it means that they did not make a purchase. You understand? They abandoned the session, and or the transaction revenue is null. So either is equal to 0 or is equal to null. So we are looking at those two criteria, and that's really what we are doing here. So that's really what we are doing here, and that's just what we have. So we have the unique session, we have the unique sessions, which is the concatenation of a visitor ID and the string. So that's really where we are. And also know that this thing is going to give us why it's going to be unique is because we have some grouping by. So this grouping by helps us to make it unique. So we are grouping by the unique session ID and the session quality D. So that grouping helps us to get unique information. So and that's just 426 abandoned high quality sessions, and that's what we want here. So we've done a lot of SQL here, and if you are just new to SQL, you may find this a little bit tedious, but rest assured, SQL is pretty simple, and it's SQL speaks English. So when you're writing SQL, you can know that you're writing just pure English. And thank you very much for staying to the end of this lab. So if you go over the resources that we've done, go over it multiple times, and you get familiar with how to use SQL in BigQuery. So BigQuery is standard SQL syntax compliance. And BigQuery has some additional functions that you may not have or that you may not see somewhere else, or that would have a different syntax that will represent that function in a different SQL editor. So thank you very much for staying to the end of this lab. If you enjoyed this lab, make sure you drop some thoughts in the comment section. Make sure you give it a like and subscribe to my channel so that you don't miss upcoming labs on our data analytics learning path. Bye for now. See you in the next lab.